Hi, everyone. Can you hear me all right? All good? Thanks for having me. Thanks for the introduction. I'm very happy to be here. I work for Interhomes, and I will tell you a bit about our motivation to go XR. So let me tell you who we are first. We're a real estate developer founded in 1968. We work throughout Germany. We build 300 to 400 residential units a year. And we have a team of about 200 employees working for us. And so far, we've built around 35,000 houses for people throughout Germany. Our portfolio ranges from affordable townhouses to high-end single-family homes and luxury apartments, so we basically do it all. Sorry? It's in the bag. It's not, I don't have it with me. Our business is very complex. We do everything from buying and developing land throughout the whole product management process, deciding what we want to build for which target group, what the architecture is going to look like, but also the public spaces surrounding it. Then we do the whole marketing process as well. All communications are in-house. We have our own sales team. We have our own after-sales team who work mainly in big showrooms where people can equip their new houses. And we also do the construction management in-house. So basically everything apart from actually building the houses is in-house. And we realized that we have sort of an issue after the first sales that are being triggered by the sales launch. It usually works quite well in the beginning to sell our houses because there are always people in the market waiting for us to start selling our homes. But after a while, it gets a bit slower and sales decrease quite a bit, actually. And we usually work with show houses and apartments. So the first house in every project we do is going to be completely equipped and decorated by us. And then our sales team uses this house to show people what our houses are going to look like when they are finished. And it's important because people get a feeling for the house or the apartment. So after opening one of those houses or apartments, we usually have a very steep increase in sales. And with this house on site, we usually have a sales speed twice as fast as before. Problem is, these houses and apartments need to be built first, so we have construction time for a house of around 12 months at least. And for an apartment in a big apartment building, it's more something like 24 months. And we all know time is money, so we were looking for something to bridge this time gap between sales start and the opening of one of our show houses. And we thought maybe XR could be the answer to our problems here, because it's obviously difficult to sell something that doesn't exist yet, especially when it's a house that people want to call their home at some point in their life. It's a huge financial and emotional investment. So by looking at a brochure or something like that, it's difficult for people to really decide whether or not that's going to be their future home. So the two main questions that our sales team always get is, what's the neighborhood going to look like? Because we do bigger projects like at least 20 units, but up to a couple of hundred units. And what's the inside look and feel of the house or apartment? Because it's very difficult to imagine from a 2D brochure or a construction plan. So we did two things. We decided to go for an AR application in order to create a neighborhood look and feel. It's an application that people can use without any assistance and completely independently from us and our opening office hours. It can be used on smartphones and tablets, and it gives you an idea of the way the building is going to look like within its real surroundings. So as you can see in the picture, this is the garden in front of our offices. And the building that you can see on the tablet is a project we're doing here in Berlin at the moment. It's in Karlshorst. It's called Dichterwohnen, and it's a complex of 10 apartment buildings, which I conveniently put in our front yard. Looks good there as well, I think. So that's the idea behind this application, to give people the opportunity to see what their future neighborhood is going to look like. In a second step, we wanted to also give the people an idea about the inside look and feel of their future home. And we decided to use VR for that, because we wanted to include this experience in the actual sales pitch. So it's a virtual walkthrough, and it's obviously via VR headset and a supervised use. Our sales team can actually see where people are looking at in the apartment. The first feedback, we've only launched a couple of weeks ago, but the first feedback is very positive so far. And if we go further with this whole XR thing, it's going to be in our Interhomes showrooms, but that's to be seen. What we did and how we actually did it is going to be presented to you by our next speaker. So thank you for your attention so far, and I'll just give the phone to you.
It's a quick handover. I don't have to even say anything. Thank you, Feline, for giving us the practical presentation. We don't have to switch anything. So you just have to press the clicker. So I'll leave it up to you. You built it with your team.
Yeah, thank you, Feline, and welcome everyone. I'd like to tell you something about the approach, how we do these projects. How do we come from an idea to a product? So there are three main steps. First, we have an idea, and we can do some brainstorming together, and design thinking is another approach that can help here. Then we go into the planning, and we create a backlog with user stories and also a storyboard. Planning poker is also a thing. I will tell you what that is in a while. And the realization phase, where we build a proof of concept to come to a product, and the user testing and advancement. So we start with the idea. The most important thing is that we have a common understanding. So everyone has the same understanding of the product. In this case, we had the clients, they want to experience their new home before it is built. So what do? We observe the user's behavior. And we see, okay, the client looks at the smartphone, sees houses there, and so he uses the smartphone to see images of the building, and then maybe he or she is going to that building to see it, but it doesn't exist yet. So basically, the user can only use images. And the question is, what will my neighborhood look like? That's the question that the user has. These questions are identified, for example, in brainstorming design thinking progresses. So we have an idea, ideation, and a product vision. So what do we do now? Now we go to the planning, and we create user stories. So we cut the requirements that we have into user stories. A user story is a simple pattern there, and we can tell a story like, okay, defined rule has a goal so that a specific benefit is done. In this example, we have a potential client, and he wants to place the building in full size so that you can see it embedded into the neighborhood. That's one of the stories that we had. And so this story alone isn't enough to the developers to do this. So we add acceptance criteria. For example, an instruction message shows up, or a crosshair is displayed. All these things can simply be shared with GUI layouts, and everyone understands then, okay, how should this look? But there are things where a GUI layout is not enough. For example, the building shows up when the screen is tapped while aiming at real-world target. So this can't be told in a simple layout, so we might need a storyboard here. So and storyboards are especially important in XR projects. We have a simple little example here. It's really basic. So we have this app where you should point your device on a given spot in front of the construction site. And as soon as you do that, the houses appear. It's a very simple, very simple sketch, but it helps to understand what is going on. And so you have this common understanding, and everybody knows, okay, that should happen. The next thing is to estimate, how long will it take, and what do we need? We have a technique here. It's called planning poker, and everyone takes part of this. The programmers, the designers, 3D artists, and even the product owner. So the client might be in the room and also estimates the effort together with the team. So how does that work? You have a story point. So everyone has a deck of cards with Fibonacci digits on it, 1, 2, 3, 5, 8, 13, 20, and you have a reference story where you know how hard it is to do this reference story, maybe a 2, and then you compare it to this reference story. And everyone holds up the card and says, okay, I think it's a 3, I think it's 5, and so you do this, and the highest and the lowest numbers start to discuss about why they think it is that effort. What can happen here? Why do we have these product owners in here? It's maybe the team, everyone shows up a 3. And now the product owner comes and shows an 8. And he might have no idea about how hard it is to accomplish this user story. But he will get the idea over time, and when he puts up another number than the development team, he might have an idea why is that so. So he has to explain, I think it's an 8 because we have to think about that and that and that, and maybe the team will now understand everything about the story. So this can lead to very exact results. So what can you do with it? If you have some scope that you have to reach, you can tell what time do you need from when to reach that scope. Or on the other hand side, you have a fixed time, and you can tell, okay, that's the scope that we can deliver in that time. So that's about the planning process. And now I would like to tell something about realization, because what we do is, let's say we want to build that elephant, a very big elephant, and now we could build a trunk and some legs, and they don't really work together. So what we do is we build a small elephant, and then we make it bigger, and then we make it even bigger, and so on. So that means that the first iteration, let's say the first sprint, is also a finished product, an MMP, a result that can be used. For example, the miniature building can be viewed in 3D here of the houses in the app. And in the second sprint, the miniature building can be placed in the real world now. So the first sprint is also a result that can be used. And in the third sprint, an additional real world size building can be placed on the construction side. So yeah, you might think now, okay, you don't really need these results in between, but yeah, you do, because you want to have some advancements. In the end of sprint 1, you can use the app, see the 3D model, and you think, looks a bit strange that there's only one house. There should be 2 houses. So you have a finding in between these sprints. You say, okay, one should place a pair of buildings instead of just one. You have this finding after the first sprint, and in the second sprint, you can place 2 buildings. The big advantage here is that the earlier the change comes, the cheapest it is. Yeah. Okay, and then after creating this, we have user testing. This works with predefined tasks, screen recordings, custom interviews, and it's basically as user testing works with normal software. But I will tell you what is the difference. The consequences are, okay, you have to improve the 3 most frequently found things. So they found a lot of things, and some users will already always say the same things, and these things can be found here, and then you can solve it very early. For example, we needed a better explanation for building placement. So it was a bit hard in the beginning to place a building, and then we modified it, and somehow it became very easy now. Yeah. So the difference between XR and a 2D project is the environment. In the testing, we had to test the app where the construction site is. So within a camera, you can point anywhere. You have these augmented reality device, and everyone uses it in a different way. And then there are these devices. You have multiple operating systems. We have an iOS app and an Android app, for example. And they have these different screen ratios. As you can see here on the right, it's the same app, but we have different screen ratios and screen sizes. So one might have a very big screen, one a small screen, one a wide screen, or a screen as you can see here. And the app has to adapt to this. Also, you have different camera qualities. You cannot do much about that, but you can recorrect some coloring there. And you have these system performances that you have to have in mind when developing for XR. I will show you a short film about the RR app, and so you get an idea of what it feels like after these sprints. So we did 2 things with this app. One thing is that you can show the house to family and friends, so you can take it home and show it on the table in a miniature version. And you can resize it, and then on the other hand side you can go to the construction side and place it there. So you can see it in real size, and you can also walk across it and find maybe your apartment in it and see it from the street. It's very impressive to see then the cars on the street maybe driving the houses on the other side of the street, and then the digital building. Yeah, and you can do a selfie with it. That's the AR side. And then Philine also told us about the VR side. So when you're on construction site, there's a container of Interhomes where you can go in and you get a headset, and there you can dive into these apartments. So these apartments are presented in the virtual reality, and so it builds up the understanding of room size, and as Philine told, we had very positive feedback about it, and people could imagine, okay, my bed fits into this room or something, and so what have we learned? What is important? We think that the Agile approach is vital. So sprint results should be usable preview versions so that we can test it in a real, easy to understand way. And the earlier these improvements are found through these previews, the most affordable they are. So if it's a law in software development, I think, that the later you experience a problem, the more expensive it gets. The next thing are the visual drafts that are vital. Drawing storyboards to build this common understanding is very important. And also the extensive testing. So the real world environment can differ in a significant way, and also the users aren't really used to use these 3D and AR contents as well as they're used to use 2D applications. Yeah. That's it, and I would like to welcome Dr. Tina Haase from Fraunhofer.
That change is going to be just as quick, I think. Thank you for your perspective on realizing it, and now we're going to get the scientific view on it.
Yeah, thanks to Malte. Thanks for having me here, and thanks for the introduction. As I was introduced before, I come from the Fraunhofer Institute. The special thing about us is that we make applied research. That means we are working very close to industry, and all the things we develop are relevant for industrial partners. So I want to talk about a systematic approach to technology selection and also the design of technology. And yeah, we have an experience about more than 20 years now for the development of virtual reality technologies. So we started very early, even before industry was ready to use this technology. And I have just brought you some technologies we are using, and just want to give you a short introduction so that you can imagine the field of technology, or the amount of technologies we are using. And I just want to start with the highlight, and this is our so-called Elbe Dome. Magdeburg is close to the river Elbe. This is where the name comes from. And the Elbe Dome is a 360-degree projection system. The image on the top right just shows the cylinder, and you can just imagine to go into the cylinder, and you have a projection around you, but also on the floor. And for being able to imagine, I have just brought a short video. No, it's not a video, it's an interactive. It should be, here it is. So this is a 360-degree image taken in the Elbe Dome. That means we have here some installations for sitting and making brainstormings there. and you are able to project an industrial environment coming from a CAD construction or coming from photos taken in this on the industrial site, and we can move around there and having brainstormings and work as if we were in the company. So another thing, of course, we are also using head-mounted displays for VR, but also for AR. And another thing I want to show you is, we call this desktop VR, because in industry not everybody wants to wear a fully immersive head-mounted display, because this does not fit to the working situations. So we also decided to use desktop VR. That means people are sitting in the training room and have a model of a technical equipment on their screen and can interact with this. What we see here is an example you see an operating mechanism. This is a part of a high voltage circuit breaker. It is quite complex, and it is not possible for trainees to train on the real device because, as you see, high voltage, it's quite dangerous. And so we developed a training system based on virtual reality technology, and people can now interact with this model, can discover this on their own, and can also simulate the functional behavior. And the special is that they can do this on a speed they determine. In real life, it is moving very, very fast in the range of milliseconds. So even if there would not be a housing around this technical device, you could not realize anything, and of course you can't explain it to anybody. So this is something we are working on. And a third example I want to show you, is I call this desktop AR, because it is can be seen on the desktop. This is an installation for an assembly, a control cabinet assembly. That means the worker has the task to assemble this control cabinet. There are many different parts, and we have installed an optical assistance system. That means you have cameras on your workplace. The camera detects what you are doing there, and you will get some augmented information on the target position of the next part you have to assemble. And so you can give assistance to the people, but we can also use this technology for testing if something was assembled in the correct position and order. As you can see now, we have lots of different technologies, and also we have lots of different applications where those technologies can be used already in the planning process for functional tests, for training purposes, where you can decide should we do the training on or off the job, but also for assembly processes. And what is now missing is an answer to the question which technology now fits best to my task. If someone is going to ask us to design, to develop an assembly assistance systems, we need to decide what is the best technology for this purpose. So what we are going to do is we have a systematic approach for this. First of all, we analyze the conditions and the objectives of technology use. Therefore, we are using the methods of work and requirements analysis. That means we go to the company, look at the workplace, get an idea of what the user has to do there, who is going to do this, what is the qualification of the person who's doing this, is there any experience in using technology, and what is the expected benefit for the person who is doing this. And in this step, it is very important not only to take into account the user that is really using the tablet or smartphone or whatever later, but there are different perspectives. You also have the management perspective, who has other expectations regarding the benefits than the one who's using the system. After that, we make a decision on the technology. So we have a first impression and make a selection. And then we need to design this technology. So I will tell you later what this means, what choices we can take there. Then usually we make an evaluation. That can be a qualitative evaluation, but also we want to get some benchmarks in terms of numbers that we compare to the expectations in the beginning, and then we will also have an update process. In practical, this means we developed such a systematic as you see here, and this systematic helps us to go to the company and to get an idea of what takes influence on the choice of technology. First of all, we are going to have a look at the job that is to be assisted by such a technology. The job, that means this is only a choice of options. Of course, this is not complete and it's even not finished yet, so we are just in the process of developing this kind of systematics. But you could imagine that first of all, you need to have a look at the task. What is the user being to support it in which task? Is he only responsible for the setup of the machine, or does he has to assemble something? And these criteria are taken before we come, so what is the current situation, but also what is expected to be realized by using an assistance systems. So it could be that the management expects that when using such a technology, it should be possible that the person can not only assemble, but can also be able to clean the machine. For us, it's really important, the aspect that people should learn at work. This is something really strange, but we have the intention that people are not dequalified by using an assistance systems. So they should really learn something. Therefore, it is important to keep their flexibility in the work process. So if you just give them an introduction, do this, then next do this, then actually it is a process that could also be automated. Then it would not be necessary to have a human being with a working head and brain. So those are typical criteria that look at the job, at the task. And on the other hand, of course, we need to look at the person itself to decide what technology fits best. Therefore, we need to have a decision on the level of competency. So is it a new person? Is it a beginner? Or is it already an expert? You can imagine if you have done a job about 50 times, you will be bored by using an assistance systems. So you won't get faster, so it's more, nerving. Sagt man so? Nervig. And of course, not everybody wants to learn at work. There are people who just go there to do their job and to go home, and they are fine. And this is also okay. So, I have here a little example. So, we are working together with a small company that makes so-called thread rolling. For the Germans amongst you, it's Gewinderollen. You have a bolt and you put a thread on it. And the machine is really, really old. Here you have an impression on this machine. And again, here we went to the company and had a closer look to the job. What do they do? And this was a very manual process, a setup process. People had to disassemble something, had to choose the right components for the setup, and even the person had to feel things. So the machine gives you some haptic feedback. And so we just try to find out what is typical as I explained before, what is, how can we fill this this matrix? And then we want to give an idea of the technology choice and design. So again, here we define some categories. One is the technology itself, and the other is the design of the technology. And here we can, of course, decide, are we going to using virtual reality, augmented reality, extended reality? Do we need a mobile installation because the machine is really big? Or can it be a stationary one, as you have seen in the assembly assistant system, because the worker is still always on the same place. And of course, then it does not make sense to give him some glasses that are really heavy, and that is not so fine to wear about 8 hours a day. And then we have here some design criteria that can be taken into account when designing such a technology. And one is, for instance, the individuality. That means the one person is small, the other is even taller. So there are some ergonomic aspects that the workplace adapts to the person in front. But it might not always be the best solution that the system itself is adaptive, because people may not understand why the system adapts to themselves. So probably it's another way that people can adapt the system, choose their phone or choose the order of the windows they have, something like that. And in this case, we decide just to use a virtual reality system. That means for the thread rolling example, that makes people understand the process, but they won't be supported directly in the work process because this is not possible, and we want to make people able to transfer their knowledge to the different kinds of threads. And so this is our current choice for this example, and that's what I wanted to tell you. Of course, I need to give a big thanks to the Federal Ministry of Education and Research, who is going to fund our project. And here are some contact information. And if you want to read something about technology-based learning and systems, I have written a short book that you're invited to read. Thank you very much.
Thank you, Tina, for that perspective. We won't really have time to sit down anymore, but may I please ask all three of you up on stage, maybe for one or two final questions to round it up. Malte, maybe a question for you. I mean, from looking at what you presented to us, it doesn't really look too much different from doing your standard IT projects, is it?
Yeah, we come from standard IT projects, so we adapt these techniques to the XR world. So we put it on the next level, and the main difference is all these more story-driven, and you have these storyboards, and you have to visualize everything, and the other things like working in sprints and so on that can be adapted to regular IT projects as well. That's right, yeah. That's our experience. So.
And I mean, as in all IT projects, yeah, managing expectations, and you mentioned that as well, is one of the important things in, well, kind of trying to solve the problems before they actually start happening. Have you experienced, knowing both worlds, the XR and the non-XR world in project development, have you experienced differences in complexity in terms of managing expectations, visualizing things or so on in XR?
Yeah, of course. Yeah, because you can't really imagine what a product will look like. I mean, that's the very great thing about VR is that you can't tell someone, okay, this is VR. You will feel like you are actually there or something. You can't really imagine that if you haven't seen it really in VR. And so is it with the planning of these projects. So as soon as you see this in VR, it becomes way more greifbar. And
greifbar, yeah. And to see, yeah.
And then you can see it, and that's why these sprints are so important, because then you have a very early access to it and can really experience it.
All right, perfect. And to make it more greifbar, I think you have a booth over there where the keynotes took place this morning and yesterday morning. So if you want to know more about it, just go by the HEC booth. You probably will be there and be able to answer more questions.
Yeah.
Feline, Tina, and Malte, thank you for coming and telling us.
I think we don't have this booth anymore.
Oh,
but,
it's already taken down on the way back to Bremen?
Yeah, but
then stick to him, yeah.
We're not only in Bremen, we're also in Berlin now. So
that's right, you just opened an office here.
Yeah, we just opened an office in Berlin, so you can reach us here or after this presentation.
And get his business card later on. All right, thank you.
Thank you.
Yeah, thank you.